All right, so this video is going to show you how to do everything that you need to work on in homework 3B, which is making all the visualizations, charts, adding titles, data labels, all that kind of stuff. This is a really important skill. And one of the reasons why it's so important, because visualization is absolutely the most important part of communicating your findings to non-data people. So no matter where you work, I mean, depending, like, we've got people in med studies, we've got people in healthcare administration, we've got people in speech and hearing science, we've got people, all sorts of different things here. If you're working with data, if you end up as someone who does research, works with data, you haven't done your own research, but you have numbers from people who have, or you pull numbers to look at in a different way from previous studies. If you're healthcare administration, you might be looking at numbers coming from your own organization on how you want to do things differently, no matter what the deal is. Oh, and if you're speech and hearing, you might be pulling speech samples from your clients. No matter what the case is, if you want to communicate what you found by doing some sort of statistical analysis, telling someone, hey, I did a t-test and this is what happens, they're not going to follow it. I know this because I do this all the time, and no one knows what I'm talking about unless they're, the other instructors of this course. So you have to visualize these things. You have to make charts, you have to make graphs, you have to do something to be able to show what you've done visually. A good graph can communicate what you're trying to say without you even explaining what you've done. And part of that is that you need to create meaningful titles and labels. Meaningful titles and labels can help people understand exactly what you're looking at quickly. And that's what you want. You want to communicate to people what it is that you're showing. You want them to know what it is. There's a quick rule of thumb that I teach my students who are, presenting research at a conference, which is if someone can look at your graph and pretty much know what your study is, you've got a really good graph. Like if someone can walk up, what we do in these is we make posters, which sounds really high school science fair, but that's basically the state of communicating science, and it has been for years, decades. You make a poster, people come around and look at it. And the first thing they're going to look at is, before they even start talking to you, they're going to look at your graphs. If your graphs look interesting and they can kind of tell what it is and they see that they're interested in it and they're like, oh, wow, I wonder how that graph turned out that way. How did that research turn out that way? Then they're going to come up and want you to tell them more. But the first thing they're looking at is the graph. You have to have a good graph. This is also true for, newspapers, communicating things in newspapers. The figure is so important. It's what brings people in to read the rest of the article. This is true for, it's not as true for journal articles, because what we do is we show people the title and the abstract. But I think it might be a great idea to start putting in a couple figures near the abstract so you can look at what's going to come up in the paper beyond the abstract and use that to decide if you're going to read the paper. I think some papers wouldn't be read at all, and more would be read that aren't currently read. Anyway, point is, the figures are so important. You have to make good figures. It's just one of the most important parts of what we do as data scientists or anybody who looks at data. Okay. So the first thing that we're going to look at is a histogram. One thing that I want to stress to you on these is you got to read the description and instructions. Don't just go crazy with the data that you have on the side, because there are things that you can get from the description and instructions that you need to know. So the data in column A are preference ratings for a new type of cookie, like Oreo 2.0 or something. 100 participants agreed to try this new cookie and rate it from 1 to 8, with 1 being very bad and 8 being very good. Values of 999 indicate missing data. This is one of those really important things that you need to know from reading the description and instructions. Create a histogram which meaningfully and accurately displays the data. Ensure you represent all the data and all a meaningful title. What? I wrote this. I don't even know what I was just writing. Let's change that. Ensure you represent all the data and add. That's what I was trying to say. And add a meaningful title and access labels. Okay. So 999s are missing data. That means if we just do a histogram right now with these numbers, we're doing the wrong thing. We have to clean this data. So I'm going to click on the top. I'm going to hold down Shift, hold down Control, and then hold down the down arrow. Selects everything. I'm going to go Data, Sort. We want to sort by column A, and we want to sort by largest. Now we've got our 3 999s at the top. And I just punched my microphone. Sorry about that. We're just going to delete those. Oh, actually, you can highlight all 3 of these. Right click and click delete and shift cells up. There you go. Now all you have is the good data that's left over. Now we're going to do the same thing again. Hold down Shift, click on the top cell that actually has a number. Then I want you to click the top cell that has a number, so 8 here. Hold down Shift, hold down Control, tap your down arrow, get everything. You're going to go to Insert. This chart right here, not the bar graph, but this one that looks like a bar graph, but it's blue. And you're just going to click on histogram. And okay, so you're like, I don't know, 90% done at this point. So congratulations. There's a couple of things we need to change. First, the bins are weird. 1 to 2.2? It doesn't make any sense. So you want to click on the, let me do this again. You want to click on the axis down here to select it. Then right click and then click on Format Axis. And there's a couple things that you can do to change the bins. I mean, first, you could put in bin width, and that's definitely an option. You can change it from 1.2 to 1. Just hit enter, and there. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. 1, 2, 3, 4, 5, 6, 7. We can also just change the number of bins to, let's say, 8 bins. Now we've got 8 bins. Everything's represented. 1, 2, 3, 4, 5, 6, 7, and 8. So every single one of our options are represented here when we do 8 bins. If you have a width that you want to use, depending on what sort of data set you're using, like let's say you have something that's a little bit finer grained than 1 to 8, you want to set up an exact bin width, and you can do it right here. If you want to change the number of bins, you can do it right here. So one thing that we can do is we can, let's say 8 is still too much for us. If we're looking at cookies, like we've got really bad and really good, but we can kind of condense these into, these two are both not great. These two are closer to I don't really care, but leaning towards bad. These are I don't really care, but leaning towards good, and these two are really good. So maybe we want to change it to 4 bins and make it something that's a little bit more intelligible. And essentially what we see when we collapse it this way is nobody really, very few people really hate it. Very few people really like it. Most people think that this cookie is either, it's fine and sort of bad, or fine and sort of good. Probably not a cookie that you want to like take out into the open, I think. Okay, so here's our histogram. We're too far down. There we go. And you want to change the title to, what do we want to call this? We want to call it something meaningful. So preference ratings for cookie prototype. Cool. There we go. We can also throw in axis titles. So here we could say number of responses. Down here we want to say axis title is preference. I would like to change I wanted to change the bins from the number that's displayed to a text, but it's fine. All right. This is good. Preference ratings for cookie prototype, number of responses, and preference. And again, depending on how you want to display this, you could do just these 4 bins. You could also do 8 bins and go back to showing each individual rating. If you do it by 8 bins, you actually see most people think the cookie's fine but kind of bad. So the way that you want to show people this, I think maybe kind of depends on like how closely your job is tied to the way that you're showing this graph. If it doesn't matter because you weren't the one that came up with the recipe, show them this. And if it matters because you did come up with the recipe, show them this. And you can say like, well, it's kind of evenly split, so we should redo it. Okay, that is our histogram. Now let's go to the line chart. Okay, what do we want to do here? The data show the 1 mile running times for experienced runners, which are labeled as 0s over here, and new runners, which are labeled as 1. And those are both under the column called running history. Both groups have undergone a stretching program and had their mile times assessed before and after the intervention. So pre-time is their mile time before, post-time is their mile time after. Create a 2x2 table using the data provided to find the mean for both groups at the beginning and end of the experiment. Ensure a meaningful title and axis labels. Okay, so the first thing we want to do here is we want to create a 2x2 table, because Excel is going to give us a better graph if we make a good looking 2x2 table. So let's add some labels in here. We'll do experienced and novice. These are for runners. Well, let's make this easier. We'll say experienced runners, novice runners. Whoa. Should have an S on it. Okay. We'll go up here and we want to do before program, after program. And now we're just going to fill in our zones. So what we want to do is we want to find the mean of experienced runners before the program. Let me spread these out so we can actually see our cells. There we go. All right, so we want to look at experienced runners. Those are 0s before the program, which is here in pre-time. So what we're going to do is equals average, and just go ahead and grab everything in this column that's a 0. So this is the mean of all the pre-times for experienced runners. Hit enter. There's the mean. Next, we want to do the mean of the experienced runners after the stretching program. So we're going to do equals average for post time for all the zeros. There you go. We're going to do the same thing for novice runners, which are ones. So we're going to do equals average. And then let's select everything that is a 1 in the pre-time. There we go. And for the after program too. Average. Everything that's a 1 for post. There we go. So the means that we have here are, 6.5 for experienced runners. Before the program, 6.1. After the program, 6 minutes, about 6.5 minutes, and 6 minutes and like 5 or 6 seconds here, something like that. Here, the mean for novice runners is about 7.5 minutes, and after, it's a little over 6.5 minutes. So let's create a line chart based on what we just found out. We're going to highlight everything. You have to get this blank cell here because you want to get the headings on both of these, and you want to get all the numbers. So grab all those, go to Insert, and now you're going to go to Line Chart, which is this one right here. There are there's a lot of different kinds of line charts. Just do the simple one right here. All right, pretty good. We have good labels already. If you put in good labels and select them, Excel will give you good labels out in your chart. So we have before program, after program, experienced runners are the blue line, novice runners are the orange line. There's a couple things we want to do. We want to change the chart title, and we want to call it like benefit. Let's call it 1 mile time benefit from stretching program. And we want to add some axis labels here. We don't really need the axis label down here because, what we're going to say is just like program status, like the time in the program or something like that. So we don't really need the bottom one. But we do want the vertical one. And what we're going to do here is we're going to say time in minutes. Nope. Okay, there we go. What else might we want to do here? There's a couple things that we might want to do. One is we can look at this axis. Let's say you don't have format axis open over here. Click on your axis, right click on your axis and format it. We got a lot of white space here that doesn't really allow us to see what the lines are doing. Now, this can be a good thing and a bad thing. What you don't want to do is get rid of this white space to like obscure meaningful data. But since we know that this is running time over here, you're not really obscuring anything by maybe cutting it down to 5 minutes. So if we make the minimum 5 minutes, we can see those lines a little bit better. And then we might also want to display some data labels. You don't have to display data labels. It depends on what you want to show. So if we get rid of that, you can still kind of tell that the novice runners are a little bit above 7.5 and come down to close to 6.5, and experienced runners start at 6.5 and go to somewhere between 6 and 6.5. So they don't have as much of a benefit, and novice runners do, but everybody gets a little bit of a benefit. All right. This is what I would put in a paper. Looks like that. Pretty good. Okay, let's go to pie chart. Okay, so what are we doing here? The data show the responses from a group of people who tried a third iteration of the new cookie, so Oreo 3.0, asking how likely they are to recommend the cookie to a friend. Data are coded 1 equals wouldn't recommend, 2 equals might recommend, 3 equals probably will recommend, and 4 equals will definitely recommend. Create a pie chart showing the frequency as a percent of the total for each response. Ensure a meaningful title and key. So the first thing we want to do is we want to figure out how many of each response there is. So we're going to count if. We're going to do equals count if open parenthesis. The range is just going to be all of this data here. So if you want, you can click, hold down shift, hold down control, and then tap the down arrow. And there's your entire range. And your criteria is just going to be 1. And that's how many ones we have. And then let's do it for 2. Equals count if range, hold down shift, hold down control, tap the down arrow, and 2 equals count if shift control down. Oh, I'm getting ahead of myself. 3, there we go. And then the last one is equals count if open parentheses, click up here, shift control down, comma 4, enter. Okay. So there we go. Let's add some labels next to those. Would not, might, probably will, and will definitely. There we go. Let's spread this out so we can see it a little bit better, and let's go ahead and grab this. Grab that data, go to Insert, Pie Charts right here, and go ahead and click on this first pie chart. Cool. So we've got would not is blue, might is orange, probably will is gray, and will definitely is yellow. So this cookie, this iteration of the cookie is like better than the other one, which is great, I guess, if you are making a cookie. We're going to change the title to likelihood of recommending new cookie. We've got would not, might, probably will. Let's add into this one some percentages. So we're going to go to plus right here and data labels. Now, this is not giving us percentages. This is just giving us the actual number of responses. You can change that by clicking on the number, then right-clicking on the number, and go to Format Data Labels. And over here, you can change it from a value to a percentage. So click on percentage. You'll have to get rid of the value. And there you go. Likelihood of recommending new cookie, 15% will definitely, 39% probably will. And then about a quarter of the people might, and 20% roughly will not recommend this cookie. It's getting better. I don't know. Maybe they'll keep at it. Who knows? Let's keep going to the bar chart. These are the same data from the pie chart question. So we're going to use the same frequency table that we made, and we're going to display the ordinal data in a bar chart. So what we want to do is copy this table. So you're going to highlight everything and Control C. You could also right click and copy. But we're going to do something special when we go to bar chart. I don't want you to click somewhere and then just Control V, because that's going to screw up. Well, it's actually not going to screw up your data, but I'm going to have you do something else anyway. Instead of clicking, I want you to right click in a cell and then click paste right here in paste options, hover over values and click on that. Why? Because, go back to pie chart. This right here, if you click on 19, this is a formula, right? Oh, and then you can screw it up so easily, just like that. So what's in 19 is a formula. What's in 27 is a formula. What's in 39 is a formula. If I copy this and put it anywhere other than B3 in my next page right here. So let's say I put it in B8 and I paste it. The numbers are different. They shouldn't be different. It's the same data. Why are they different? Because now it's COUNTIF A7 through A106, which isn't right because our data doesn't start at A7. If I pasted it into B3, it would be correct. So what's happening is Excel's moving this formula. It's tying like where the formula starts to where this is pasted. So if we go back, I copied this from B3 and it's starting at A2. So it's going like up diagonally, just one, from B3 to A2. Boop, boop, like that. We go over here. This formula starts at A7. Well, guess what? It's one up diagonally from here. Here's B8. Here's A7. So it ties it to wherever you're pasting this, which is fine if you put it in exactly the same place. But if you don't put it in exactly the same place, it's going to screw up your data. So to make sure that I had the same data over here, I did right click and paste values. Okay. Let's make a bar graph. We are going to highlight the same stuff that we highlighted for the pie chart. Grab all those and then go to Insert. This time we're going to click on this one right here. This was histogram, the blue one, and this one with different colors. This is a bar chart. Just go for the first one here. And look, there's our bar chart. Let's type into this likelihood of recommending new cookie, and now we're going to want this axis down here. Again, I think is pretty self-explanatory based on the title. We're just looking at the likelihood of recommending the new cookie. We might need something over here. So for our horizontal axis label, or sorry, the vertical axis label, we want to say number of responses. Okay, there we go. Number of responses. Likelihood of recommending a new cookie. Wouldn't, might, probably will, and will definitely. So this way you can actually more accurately see that more people would not than would definitely. But probably will is a significant size of people. I don't want to say significant because we haven't done a test on it, so that's why I'm stopping myself. It's a large contingent of people. I don't know. Making cookies seems hard. Okay, let's do a box plot. This one might be getting... it's a little more complicated. Each one is kind of like showing that you know how to do another step in the group of things that you need to know. So, the data show 5K race times for runners who both did and did not participate in a stretching program prior to their race. The age and weight of runners varied. Create box plots to display the race times for runners who did and did not participate in the program. Do not include extraneous variables. Ensure box plots are on the same chart and have a meaningful title. So what are you actually doing here? What you're doing is you want to make a chart that shows race times for runners who did and did not participate. Nothing about age, nothing about weight. It's just here. Because this is the kind of thing that you're going to get out of real data. You collect all sorts of variables that you might not actually want to look at. We always collect age to show that our age is representative of a certain population. We always collect gender information to show that we're, representing gender in the sample too. Like if it's all women, then you can't say that that necessarily is representative of men. And if it's all 20 to 25-year-olds, you can't say that that's necessarily representative of 78-year-olds. So we're definitely going to grab age. We're definitely going to grab gender. Weight in this study is probably a covariate to show why some people have different race times, even though their age might be the same. So there's stuff that you grab all the time that you don't actually need. But what we do want are race times. So let's go ahead and grab the race time out of this one. I'm going to control copy that, and I'm going to paste it just anywhere right here. Boop. Now I'm going to get this race time, control copy, and I'm going to paste it right next door. And then we have a problem with our labels here because they both say race time. So I'm going to grab, let's just grab runners who participated and throw it in here. I knew that was going to happen. Because this spans 3 cells, it tried to span 3 cells here too. So we're just going to type this in. Participated and did not. There we go. Now grab all of this data and come up here to insert, and we're going to go back to the histogram area. I'm not really sure what to call this. Histogram tab, something. And below the histogram, we've actually got box and whisker plots right here. Go ahead and click on that. And look at this. We've got 2 box and whisker plots right next to each other. We got a lot of white space down here, so we're going to have to get rid of some of this. Let's go to the axis over here, right click, format axis. It looks like our minimum time for, what is this, a 5K is 20 minutes. That makes sense. Okay. Now we can see that there's a little bit more differentiation between these. They looked kind of the same, and they shouldn't. One way that you can tell if your box plot is correct is to look at some of the 5-number summaries that we've talked about in relation to box plots. So we want to look at the max. Let's look at the max in participated. So equals max, and then we'll just select all these. And let's look at the min. And then let's also look at the, let's look at the mean. Okay, and then what? Oh, every time. I do this for a living. Average. Okay. And then to move these over, just select all 3 of these. Go down to the little magic clicky thing, and where your cursor goes from big and white to small and black. Pull over, and now you've got the same data for over here. So let's see if these look right. So our max for participated is 34.2, just slightly above 34. Yeah, looks good. Our min is 23 point something, and this is 23 would be right here. So yeah, it looks right. And the average is where this X is, and well, I'm hovering on it, and it says 27.96, which is exactly what our mean is. For didn't participate, our max is 31 point, almost 32, which is right here where we are. The min is 23.8, so pretty close to 24, which is where it is. And the average is 28.32, and if we hover on that, I wonder if it'll show us. 28.32. Great. So remember, with a box plot, the separation between these two boxes is the median. Like the line here that's separating the two is the median, and the X is the mean. So you actually get a look at how close your mean and median are. In this case, they're really close to each other, so both of them are a good approximation of central tendency. Depending on what you're looking at, they're not going to be close to each other. So like we've talked about salary, if you look at salary across the entire United States, the average and the median are like not going to be right on top of each other like this. The average is going to be way higher. The median is going to be way lower. This is true for, different sets of data. The reason why it's important to look at these, both average or mean and median, is because you have to know what kind of data you're dealing with. Is it something that the median and the mean are on top of one another? So we consider that more like normally distributed, or is it something where they're not on top of each other, where they're skewed one way or the other? Okay, so here's our box plot. What do we need to do? We need to give it a good title. Chart title is going to be race times, 5K race times for runners. As a function of stretch. I don't know if I like as a function of stretching. We're gonna cut that back to 5K times for runners by stretching participation. Yeah, that's a little bit better. Okay, cool. Let's now do some axis labels. We want axis titles. I think we're only going to want our vertical axis again. This axis title is going to be 5K time in minutes. And then we want to fix the legend here because I don't like the fact that it just says 1. So we need to format this axis. No, I need to add something. There we go. Let's actually just get rid of this axis since it doesn't let us add this. Delete, there we go. So what we did here is we added the legend. Legend. And you can change where you put it. So you can put it at the bottom or the top or whatever. I'm going to put mine on the bottom. So 5K race times for runners by stretching participation, and we see, that, I don't know, maybe it helped for some people that participated, but the means aren't really all that different. And one person in the participated group took forever to finish that 5K. Actually, that's not a bad time. If you run a 5K in 34 minutes, you're still doing pretty good. I mean, you ran a 5K. So that's great no matter what. Okay. Now, if you could do this, you're done. But not everyone can get this box plot to work. So if you can't get your box plot to work, we're going to go to this manual box plot thing. On your homework, 3B, if you can do this, you don't need to worry about this page. Don't even worry about it. But if you do have trouble getting your box plot, you can compute all of these things over here. So what you want to do is fill out the information in all of these different boxes, essentially. So you can do that by typing in equals min and then selecting race times here. For quartile 1, we're going to say equals quartile, returns a quartile based on percentile values. Yeah, okay. So we'll do this quartile.exe. I'm used to quartile here, but this is like the old one. So we'll do the new one. Oh, I see. Exclusive and inclusive. We'll do quartile inclusive. Array is just where your data comes from. So you're going to do equals quartile.inc, and then your array is just where your data comes from. Like when you do the min, you select this data. That's the data array. And then we want to... Oh, look, you could do your minimum from right here in the same place. Oh, well. We want to put in 1 because we're looking for the first quartile. So we'll type in 1 and hit enter. There we go. Now, you can do equals median, and we'll do that. Equals median. We're just going to grab all this data here and hit enter. 28.18, because the other thing I saw was you can do equals quartile.inc. The array is this, and we can type in 2, and that'll give us the median value. And guess what? It's the same thing, 28.18. So you can use whatever you like in this case. Quartile 3 equals quartile.inc. The array is, just your usual old junk. We're going to put in a 3. We're going to hit enter. Great. And then we can do max, which you can do equals max, or you can do equals quartile.inc. The array is here. Grab it, comma, and then what is it? 4. There's your maximum value. 34.24. You're going to want to do the same thing over here as well. So I'm going to do that really fast and not say anything. Okay, there we go. There's our min Q1, median Q3, and max. And now we got to do some calculations here, and this graph is going to fill itself in as we go. So for the minimum, we're just going to say equals the minimum right here. Just arrow up until you get it, or you can click on it. Quartile 1 minus min, we're going to say equals quartile 1 minus min. Enter. For our median minus, let's make that bigger. Median minus quartile 1. Actually, I'll tell you a secret. We can just drag these all down. Bloop, like that. Because our formula for quartile 1 minus min is B34, right here, minus B33. Well, median minus Q1 is going to be B35 minus B34. So if we drag these down, B35 minus B34, B36 minus B35, and B37 minus B36. Cool. Done. And because this is the same thing that we're doing here, we can copy all that. We can highlight those, drag it over, and there we go. And here's our box plot. It looks similar to what we have. It's just turned on its side. There we go. You got to give it a name, and you got to add some axis titles. But we've done that already. So just follow what we did on the other one. And that is it. So what you have is you have the blank file where you can do your work. I'm also going to upload the answer sheet, which is basically this, what you're watching. I'm just going to save this as an answer sheet and upload it. And so you can follow along and then check your work against this video and the answer sheet. Pause during the video to make sure that you're doing all the steps correctly. And then you should be, once you can do all these, you're ready to go to homework 3B. Try to do 3B very well because, like I said, it is the most important thing. If you do data work, you can do all the cool like tests you want to do, but if you can't make them intelligible to people who are not data scientists, it doesn't matter. It doesn't matter. You can like slave away and do all this cool stuff and then nobody's going to look at it. You have to make them understand what it is that you're showing them. So, you know, like if you showed somebody this and you said like, look, we could do this stretching program. And we'd spend like $1,000 getting people to do it, and they'd be like, "Well, that's like a bad idea because it doesn't help." And you'd say, "Yeah, okay, that's true. That's true." Back to the drawing board on this thing. This is not real data, by the way. I think a stretching program actually probably would help people get faster. I don't know. I haven't looked at it. This is a question for actual research. I just don't want you to think that it doesn't do anything because I made these numbers up. Okay, that is your homework. Good luck.